today's session will be about experiential learning. So we just saw the different teaching methodologies that we will be using to teach a particular topic and to get the learning objective passed across to the students. So there are different ways in which we can pass it on to the students. And one of the most very important ways is experiential learning. So when it comes to mathematics, it's all very abstract. It is not like science where we can show a leaf and then say this is the leaf. The children can actually see the leaf. Even when we go to higher classes, when we talk about a cell or a nucleus or a vacuole or anything for that matter, it can always be shown at least under the microscope, even if it is not available to the naked eye. But in mathematics, everything is very abstract. Nothing can be shown to the children. Like we say factors, we say multiples, we say division, denominator, numerator, isn't it? Dividend, divisor. So nothing is concrete. As far as mathematics is concerned, nothing is concrete. Nothing can be shown physically to the students and everything is abstract. So how do you explain something that is very abstract to a child? So what is the vision does he have in his mind when we say fraction? We put a line, we write something on top, we write something at the bottom. So all these abstract ideas, how do we pass it on to the children? So we have something called as experiential learning, where they do all these concepts, where they perform these arithmetic concepts, and then by doing, they internalize these concepts. So that is what is the theme of experiential learning. So what is experiential learning? Experiential learning is learning by doing. By doing, we get an experience. Supposing, for example, when we were small, our parents would have told, don't go near the candle, it will burn you, isn't it? But we don't know what is burning. That word burning, or it don't go and touch the stove, it is hot. We don't know what is hot, isn't it? So we don't heed to their advice, or we are very curious. We go and then we touch the stove. We go near the candle, then we feel the heat. That gives us an experience, isn't it? That gives us an experience. So for the next time, we never go to the stove. Even when our parents don't tell anything also, we don't go near. Why is that so? Because we have the experience. We have internalized that experience. We have not seen what hot means. We have not seen. What cold means, we have not seen. But we have experienced what is hot. So we don't go near it. And that is a valuable lesson that is learned there because of the experience we had. So many times we would go very fast in a scooter, fall down somewhere, and then we resolve ourselves to go very slow. Isn't it? Because of the experience we had. We always tell, yeah, I had an experience like this, so I will not do it again. Even with a few people, we say, no, I don't want like that because I had a very bad experience with him or her, something like that. So every experience teaches us so many things. So experience, as adults, we all agree that experiences matter. So as teachers, is it possible to teach all these mathematical concepts that are very abstract to children through experiences? So this is what is the crux of experiential learning. So since the concepts are very abstract, can we design activities through which children do them and then they learn? So because we have always seen that what they see, they remember for some time. What they learn, they remember for some more time. But what they experience, they never forget. So as teachers, we must create opportunities in the class for the child to have experiences. Then the child never forgets. So for example, we can, and the experiences can be a very small one.
Sure,
because here, yes ma'am.
I just like to add a sentence here. Not only inside the classroom, around the
or in their surroundings. It can be or in their environment. Definitely the opportunities can be created in their environment. There are a lot of opportunities that they can experience on their own. It need not be created only by the teachers. Of course, inside the school, the teachers create a lot of opportunities. At home, there are various opportunities that are open to them in nature. So that also definitely they can experience, because as one of them have suggested, counting the number of flowers. Yes, of course, that is what I'm trying to mean also. Opportunities are open to them around and everywhere in their surroundings. So definitely they can make use of those opportunities and get a better learning experience. And here we would like to add one more additional point. When it is, of course, I don't know how many of you have done Montessori training or Montessori courses or heard about the Montessori courses. There, especially for primary children, they insist on touch and feel, because that leaves a long lasting memory in their building. So touch and feel would definitely give them a better experience, because many a times children may not be able to visualize what we are saying. Okay, see, for example, ma'am has given a vegetable. She has just cut the vegetable into different shapes and may had created what are the shapes. And of course, the shapes that we observe in each vegetable also. For example, if you take carrot, almost it looks like a cone. But there are certain children, if you talk about, say, a radish or a melon or whatever it is, they may not be able to visualize, or some of them wouldn't have seen. Suppose if you take a first standard child, they may know that particular fruit or a vegetable or that flower in their regional language. But in the class, we almost we use only English as a medium of instruction. For that particular matter, they may not be able to relate, okay, this is a fruit that ma'am is talking about. So it is always better to bring the fruit or the vegetable or the flower or even a small object, whatever it is, to come and show it in the class, touch and feel, and then there is a lot of difference in simply visualizing the object rather than seeing it directly. I think teachers, all of you would agree on this. Am I right? Many a times, even sometimes
Yes, ma'am.
as adults also, we don't visualize, because we may not have the chance of seeing certain things or visiting those places. Yes, definitely it is not possible for everybody to have that. So either it can be represented pictorially, or if possible bring that object, or it can be a small video like how we suggested yesterday. So all this will add on to their learning part. Yes, ma'am.
So like ma'am said, we can use vegetable stamps, even climbing stairs. You just number the stairs in the school and then ask them to go up and down. They will learn so many things doing that, like ascending order, descending order. They learn the number line, they learn the largest, they learn the smallest. So all these simple things we can teach them through experiential learning. And of course, what we saw yesterday, enacting grocery shop, being the shopkeeper, being the customer, being a banker. So all these gives them the experience of doing things actually. When we say this is profit, this is loss, they don't understand all those terms. But when they actually experience, when they see the extra money which they have in their hand, then they realize that, okay, this is the profit. This is the extra thing I have spent for this. So I have to ask over, what is an overhead cost? Should it be added or should it be subtracted from the cost price is the, is the confusion they have at all times. So when we give them an experiential learning in all those areas, I think they understand all those concepts better. So now we will see the difference between traditional versus experiential learning. Of course, traditional learning, as we saw yesterday, is teacher-centric, focused and one-way delivery of all the concepts. Here, experiential learning puts student in the center. It's always student-centered and student-focused. And in traditional method, the learning outcomes are prescribed to a fixed rubric or a scoring system. It's only when we see the answer what we need in the paper, then we grade the students in the traditional learning system or in the traditional grading way. So learning outcomes can be flexible and open in experiential learning. For example, you can have a few marks as internals for the experiential learning activity of the child, and then you can grade her on this activity. So the child will also benefit out of this experiential learning activity, because end of the day, she is also getting some marks out of it. And then, and in traditional learning activity, we have to explain the knowledge or skills only by transferring the information. We give them formulas, we give them fixed rubrics, and it is through that we are transferring the skill. But here in experiential activities, they get to do it, they get to experience it, and then they learn that skill. And of course, traditional learning activities have fixed structure and a high degree of facilitation. What do you mean by facilitation? It has a high degree of direction from the teacher. The teacher has to repeat the formula 3-4 times, make the children write in their notebook, make them by heart by rote learning, and then make them apply to the problems. But here, experiential learning activities, it is a flexible structure with minimal facilitation. The teacher need not explain the concept, because the students are in the situation where they experience the concept and they learn it. So these are all the differences between traditional and experiential learning in a very broad area. Teachers, if you can come up with more differences between the both activities, you're welcome to share it. Yes, teachers, any more differences you can see between traditional? Yes, teachers. I think definitely you all would agree that the classroom and the learning environment will be more vibrant and active with the experiential learning activity method, isn't it, teachers?
Yes.
This helps sometimes students to deduce the formula on their own instead of re-giving them instructions.
Huh?
Yes, ma'am.
Can you be a little bit loud?
Yes, ma'am. She has put it in the chat. Like they estimate. Yes, ma'am. When we talk about experiential learning, of course, they learn a lot of estimation. Earlier, when it was a rote learning, they would definitely not estimate, like how we discussed in our previous topics. Like if you ask them to find the average, the nearest weight of 3 apples or 2 apples, they would write definitely in kgs, 2 kgs, 3 kgs. But if they experience the weight of 1 apple using a small weighing machine that is available in the MATLAB, they'll know that it is hardly some 120 to 150 grams, maximum 170 grams, that's all. So it is in grams, that is not in kg. So definitely they will learn how to estimate. And when you look at the classroom, the size of the classroom, many a times we have a blackboard, and we would have already shown them the size of 1 meter scale. And if you just ask them to estimate the length of the blackboard, some of them they go either at the higher end or they come to the lower end. They are not able to estimate. So if they could analyze, here the word analyze, I'm using it because they know what is the length of 1 meter scale. The teacher would have shown it in the class, and the children would have felt it, they would have touched it, they would have kept it on their desk, and they would have measured the length of the desk. So by then they must be able to estimate how many such scales would be the length of the blackboard or the breadth of the blackboard or the height of the classroom, for that matter also can be questioned. They need not climb the walls and find the height of the classroom. They can estimate. So these are the things which are definitely useful for them when they do the methods that we adapt here, like experiential learning, art integrated learning, which is next to come in the next class, all these things are definitely helpful for them. Yes, ma'am, somebody has mentioned the length of the classroom. Yes, that's what I'm trying to talk about. So they'll be more interested to do some more activities which the teacher is not telling them also. The next day you will be wondering, they'll come up with the estimation of the length of the corridors. They'll come up with the length of the stage. So many things. The next day they'll come and tell you, ma'am, this is the size of my living room in my house. So it will be very nice. So this creates a lot of interest towards the topic.
Ma'am.
Yes, ma'am. Please continue.
So when we say experiential learning, like ma'am said, we have to bring in the use of manipulatives. So what do you mean by manipulative in mathematics? Of course, as we say, manipulative, to manipulate has so many meanings in language, but what does manipulative mean in a mathematical language? So in mathematics, a manipulative is an object which is designed so that a learner can learn some mathematical concept by manipulating the object. So the use of manipulatives provides the children to learn concepts through developmentally appropriate hands-on experience. And the manipulatives help make abstract ideas concrete. So you can see, you can use all these counters and tiles and whatnot, colored sticks, cubes, for that matter. Whatever that is used to teach mathematics is a mathematical manipulative. Even this paper plate that is being used to teach fractions is manipulative. Why do we call that? Because it is a paper plate, but we are manipulating the usage of the paper plate. Because the paper plate is not meant for that. We are manipulating the paper plate to teach something that is the concept of mathematics by using it to teach the concept of fractions. That is why here it is being used as a manipulative to teach mathematics. Why? Because fractions are very abstract. So when we say half or 3 by, when we write just 3 by 4, 3 parts out of 4 parts, the child does not understand because she has not actually seen what is 3 parts out of 4 parts. He has not seen something which has been cut into so many parts. So now we always take a pizza as an example, isn't it? When we teach fractions, in the first or the second example would be the pizza. Or we take a collection of 5 flowers. In that 3 flowers are red or something like that. So we use manipulatives. So all those things which we use to teach a concept in mathematics are called as manipulatives. So in experiential learning, we definitely have to use manipulatives, and all the manipulatives need not be very expensive or to be bought at the store or anything like that. It can be as simple as buttons or even grains of rice or even beans. We always ask children to bring a handful of beans when we ask them, when we teach them addition, borrowing, because after 9, the one bean goes to the next place. So it can be anything, starting from beans to grains of rice to buttons to paper plates to paper cups. Anything that is being used to teach a concept is called as a manipulative in mathematics. And experiential learning is all about using easily and locally available manipulatives in a best possible way to teach a concept. So now we go to the core of the concept. So there are 4 stages of experiential learning. So we say there are 4 stages of experiential learning. So the first step would be the concrete learning. Next is the reflective observation. Next stage is abstract conceptualization. And next stage is active experimentation. So when we say a concrete learning, what do you mean by concrete learning? So here, this is the stage where the child is actually doing it. Supposing we are giving an activity, like say in the paper plate, she is doing the fractions. So this is the stage.
Just a minute, ma'am.
Yes.
ஆனா 3 நாள் அதுல தூங்கிட்டு
Teachers, can you please mute?
டென்ஷன் தான் ஆகும். ஆனா தூங்கிட்டு அப்படியே சாப்பிட்டு
Yes, ma'am. So concrete learning. So this, for example, when we ask the child to do represent a few fractions on a paper plate, say half, 1/4. So the concrete learning stage is the stage where the child is actually doing it. She's actually doing it, and she gets the new experience. She learns the new experience of how she has to use fractions on a real life basis, and she understands fractions. When she colors half the plate and she writes 1/2. When she colors 1/4 of the paper plate and she writes 1/4. So these are all the places which gives her concrete learning experience. So that is the first stage. It is the concrete learning stage, and then reflective observation. What do you mean by reflective observation? After having that experience, she reflects on that experience. As we say, when we go and touch the hot stove and then come back, okay, we have got the learning. We got the experience, which was the hot touch of the stove. But what is the reflective observation on that? That would be, this is hot, this will hurt me, and so I will not do it again. That will be the reflective observation of that experience. So for the child who's doing the fraction, the reflective observation would be, okay, half of any object, half of any collection will be represented as 1/2. Half of that, or 1/4 of the entire collection, will be represented as 1/4. So if in a paper plate it is like this, when I do half of 8 apples, it would be 4 apples. So these are all the reflective observation which the child will have after having the concrete learning. So next comes the abstract conceptualization. What do you mean by abstract conceptualization? She internalizes the concept. She internalizes the concept of fractions. That would be, because 1/2 is one part out of 2 parts. 1/4 is one part out of 4 parts. So now extending it to the concept of fractions. So when the teacher says 3/5, I have not done 3/5, but I can understand what is 3/5 because I have the reflective observation. What is 3/5? Something that is cut into 5 parts, and I'm selecting the 3 parts. So that is the abstract conceptualization. The concept which is abstract has now become a practical thing for her. She understands, she visualizes what is that. And then next step is active experimentation. What is active experimentation? Having understood all this, she goes to the next level with what I can do with this experience. So next, when we have the, when I say about experiment of the stove, when we come to the abstract conceptualization, we can understand that all things that are there with heat are dangerous to touch. This can be the abstract conceptualization for us. So active experimentation, in the sense, we would say, next time when we see something hot or on the stove, I wouldn't touch it, or I would use some cloth to lift the pan. I would wear some gloves before I lift it. So we tend to bring in so many things and then actively experiment with the knowledge what we learned, isn't it? So when a child comes to fractions, then she thinks how to use this knowledge. Maybe when I want to compare fractions, when ma'am has given 1/2 and 2/2, I use this knowledge to actually experiment and decide what do I do with those fractions. When ma'am has told me to find equivalent fractions, when ma'am has told me to find a lesser fraction, has given me 2 fractions and have asked me to find which is lesser, which is greater. So how do I compare? How do I visualize and then compare? So all that comes under active experimentation. So these are the 4 stages of experiential learning. So first step is concrete learning, when they actually do the experiment and learn it. Next is reflective observation. They sit and think back and reflect on what they have done and learn a few things through their experience. Abstract conceptualization is where Because of the reflection, they learn the abstract concept, and active experimentation is they apply all these things to further problems and to further move ahead. So this is what is Cole's experiential learning cycle model. So based on this, he had said, so first activity activity would be what happened. So that is the experience, isn't it? So when you color the paper plate, what has happened? How does the plate look? When I touch the stove, what happened? So these are all the facts. When I do the activity, reflection would be the feelings. How did I feel when I touched the stove? How did I feel when the paper plate was complete? What did I notice when it showed the portion half? So these are all feelings, and conceptualization is finding. Why did that happen? Isn't it? So when I colored 1/4, how did it happen? Why did that happen? Why did I select only that portion? And application. This is for future use. So how would I do with other fractions in future? So these are the 4 cycles of the experiential learning: activity, reflection, conceptualization, and then application. So experiential learning is like you can read n number of books about cycling, isn't it, or swimming. After reading all those books and passing an exam, will you be able to ride a cycle? Because someone has given you a certificate that you can cycle or swim. Can we, teachers? Can we do it? The teacher has given you 2 sessions on how to swim. Put your left hand this side, put your right hand, rotate it. You should breathe when you go inside the water. She has given you so many tests. On... Yes, sir.
Yes, sir. You're not able to hear. It's okay, ma'am. Continue.
Yes, sir. So
only that learning experience
yes.
of
So that is
or swimming or reading or walking, or even for that matter, even sleeping, everything we by experience only we are able to feel that and observe.
Yes. So how much ever the teacher has told in the class and we have passed some tests, unless we jump into the water and swim, unless we sit on a bicycle and learn to balance ourselves, nothing is going to happen. So that is what we are trying to do with mathematics as well. How many ever we explain addition results in something more, subtraction, the answer will be less. We often find children subtract and giving an answer that is more. Isn't it? We always find, because they have not internalized the concept. Sometimes children add, they leave some number in the hundreds place, they give an answer that is less than the add-ins. Why? Because they have not internalized the concept that when you add, the answer is something more. So when we do that, at least the numbers, if they go wrong, we can accept, but the concept that the answer must be more. At least that awareness must be there when they add. That the number must be less than the minuend, the concept must be there when subtraction is done. So all those concepts can be internalized through experiential learning. That check at least the children can do, if not for the numbers. So next is, all these concepts are a bit in-depth for experiential learning, but I would just like to touch upon all those, because as teachers, if we are knowing all these broader areas, it will be helpful to train to analyze the children's learning behavior and then give them a more apt methodology. So as we say, the first step is concrete learning, reflective observation, abstract conceptualization, and active experimentation. So these 4 combinations of perceiving and processing determine one of the 4 learning styles of how people prefer to learn. So some people, they love doing things. Some people in class, you see, they don't like doing things. They only like to watch. They only like to watch. Some people like doing things. Some people, they do things, but they don't learn from those things, isn't it? Even in life, we see, and we always tell, last time you did this, Again, you're repeating this. Why didn't you learn from your experience, isn't it? So some people are very good in reflective observation and some people are not. Some people, having learned all the concepts, they are very poor in applying those concepts. That we can see so many times, because you teach 2 word problems and you give a 3rd word problem, they will not be able to do. Unless we put the numbers and put the symbol plus or minus, they will not be able to do, because they have difficulty in applying the concept. Yes, perfectly they understand the concept, they are clear with the idea, but they are very poor in applying. And some people, they are very good in applying, but they will not apply it in real life. If you give a real world problem which apply something in real life, they are not able to do. But if you give them as pure mathematics problem, they are able to do. Why? Because they cannot connect the concept with the real life. So these are the 4 stages. And what David Ford says in his experiential theory is, each child is strong only in a particular area. Naturally, is strong only in a particular area, and through experiential learning, what we should identify is what are the weaker areas of the child and strengthen those areas so that a child is able to learn, reflect, and internalize the concept and also actively experiment the concept. So by making the child strong in all the 4 areas, we can do a really good job of making the concept clear to the child. So that is why the 4 combinations of perceiving and processing are very, very important in experiential learning theory. So the 4 styles, he gives the names of the first style is the diverging style, where the children are very good thinkers. They are very good in imagining. So when we ask something out of the box, we see 2-3 children always answering in a
Different
very
style.
well, isn't it? Out of the box thinking. They can always visualize the concepts very nicely, come up with out of the box answers. Next is converging style and assimilating style, accommodating style. Assimilating style is they can assimilate all the information and then they can apply it. Assimilating style, they are very good in application. So you teach some concept, you give them some word problems, and even before teaching them, they would say, yes, ma'am, you can apply this. When you teach fractions, they would say, yes, ma'am, that is why when you are giving paper, I have seen fractions. They relate to fractions immediately, because in papers we put their marks, isn't it? 75 out of 80. So when we ask, have you seen fractions anywhere in real life? When all the children are busy thinking, they would say, yes, ma'am, it is used in answer sheets. When teacher give, it's always there. And now only we understood what is that all about. So we explained that, yes, we put 75 by 80 because that fraction represents the number of correct questions you have written out of the total number of questions. So that is what we explained. Okay.
Very simple example would be the number of absentees in the day-to-day basis.
Yes. So when we teach fractions, we can always use the math wall to write fraction of people present, fraction of people absent. So they will enjoy.
There it becomes very concrete because they visualize that in their particular classroom. How many of them are present, and they know to name the names of the students also, those who are absent and those who are present. So that becomes very concrete for them. They experience that, they feel that, they see that in the class.
So those are the children who have a very good assimilating learning style. Converging learning style, they love to solve problems and apply whatever they have learned to practical issues. They always have a better understanding of abstract ideas. Then accommodating learning style, they always prefer practicality. Whatever you teach them in a practical way, they are they understand it very easily. So in a class, it is a heterogeneous mix of children, and we have children who learn, who have learning styles in a diverging way, assimilating way, converging and accommodating. And by doing experiential learning, it would benefit students across all these 4 learning styles. That is why they say experiential learning is very important. And here, these are the 4 learning styles which we just discussed, which is just interposed in the experiential learning cycle. You all can, if this is too complex for you, you can just understand that there are 4 learning styles, and by doing it, all 4 learning cycles, students with all these 4 learning cycles can benefit out of experiential learning cycle. If you are interested to delve more into all these concepts, of course, you can do a self-study, which is not, which is more important maybe on a psychology basis. But as primary teachers, we just need to understand that there are so many things underlying here, and to make a note of all this. And now, importance of experiential learning. Definitely, we all agree that giving experiences would definitely help them learn more. So makes learning relatable to students. Why should I learn fractions? Why should I learn measurements? Why should I learn what is more, what is less? Why should I arrange in ascending, descending? All these mathematical concepts, how would be related to real life? Why should I learn about that profit and loss chapter? Where am I going to use? Because I am not talking profit and loss in the house. My mother is not talking about profit and loss, cost price and selling price in the house. Where will I use this? Why am I learning all this in class 4, class 5? So it makes learning relatable to students, because when they go to a shop, even though these words are not being used, they understand the mathematics behind these real life situations. Increases the effectiveness of learning. Of course, when we explain n number of times, that is always better than making the child do it once or twice. Links theory to practice. That is very important because it connects them to real life. Increases students' engagement. That is really true. We all know that on a hot day or after lunch, we have a math class, or after a PT period, we have math class. That's it. There is no attention in the class. Everything goes for a toss. Everybody wants to take rest, or after lunch, they are so tired, they want to sleep. So all those times we can have experiential classes with some student engagement, because the student is able to move around the class. And all, even if we have 5 or 6 students doing an activity in the class, other students are at least eager and give their engagement to see what is going on. That is always there when an activity is going on in the class. Assists in memory retention, because the experience they have cannot be taken away easily. So assists in memory retention. Leads to development of skills for lifelong learning, isn't it? So when they go to a shop, they relate immediately and they learn something. So they always are eager to open their minds and see where they can learn mathematics. So when you say 5, or make a note where you see 5-digit numbers or 6-digit numbers or international place value system, you make a note of it. You give them a month and say, so immediately when they open the newspaper, they see some 6 billion reserves of oil are used in the Gulf or something like that. They see all those. Or if you say, you see where you see decimals in real life, they open the weather forecast, they see 37.5 degrees, or they see a news about earthquake like 5.2 on the Richter scale. Wherever, I'm just giving a few examples, you will be amazed as to see how children bring about 5 or 10 examples where they have seen large numbers and where they have seen decimals. So they're always open to learning.
To relate what they have studied and what they are observing, what they are viewing, what they are reading, everything they are able to relate and understand it even more better. That is why always whenever we teach certain concepts, this how, why should I learn this? From where do I get this? Why, what, where, how is very, very important. If the child starts questioning, it means definitely they are learning something. Why should I learn this? Then we are definitely in a stage to give an answer for that question. Where is it used? Yes, like as ma'am said, where am I going to use this? The child may not be able to use it immediately in her life, but in the later cases, this particular concept, what she has learned in lower classes or in the primary classes, is going to definitely help her in the college, or even after that when they grow up and become adults. Because After becoming an adult, nobody is going to sit and learn what is addition, subtraction, multiplication, division. All that is taught in their formative years. So these are very, very basic concepts which, like ma'am has suggested, leads to development of skills for lifelong learning. Throughout their life, these concepts are going to be there, whatever they do. It need not be only money, it can be any materialistic things also, but these concepts are there throughout their life, without which we cannot do anything for that matter. So this idea has to go into the child's mind. Only then, if that idea is concretely put into the child's mind, here it is not, I'm not saying abstract, when it is put concretely into the child's mind, then they develop a interest towards the subject. Many a times we see children getting bored about the maths classes just because it is not made interesting. Many a times we have seen that. It will be like simply a rote method, teacher going on giving instructions and the children are able to do. She'll put up some 2 sums on the blackboard. She will explain that. Then she'll put up some 5 sums and ask them to work it out. Let that not happen here afterwards. Before beginning that chapter or before beginning that particular subtopic itself, make it very, very, very clear to the children where are they going to use it. After all these points, I'm going to come to you teachers. There are few chapters where we ourselves are not sure where they are going to use and how are we going to relate that to the real life examples. I'll come to that later. Let ma'am finish that. Then we will all have a discussion about those topics which are there in the primary level itself. Yes, ma'am.
Yes, ma'am.
Go to the next, ma'am.
So next one, so how can we plan a few experiential learning activities? So few methods would be cross-age peer tutoring. So cross-age peer tutoring would be peer-to-peer tutoring also. We can ask, supposing we can have a session where after taking a particular topic, we can ask students to teach one another. So that is always helpful because as we discussed in the earlier classes also, students are very, some students are introverts. They would not like to ask doubts in front of the class before everyone. So they are very free when a peer is teaching them. That we have always noticed. We would say, okay, you go and help her learn the problem. After 10 minutes, the child would say, yes, ma'am, I learned it, because the peer would come down to her level and teach her what she has learned, and she would also understand her language, and she's very free to ask, how did you get 1 here? How did you get 2 here? And all that. So cross-age peer tutoring. It could also be higher classes teaching lower classes. We have that program in our school where classes 6, 7, 8 come and teach classes 1 and 2. They're also excited to learn from their akkas for the whole day. So we have this cross-age peer tutoring in our school. You can also arrange it in your school if you...
Not for the whole day, a few sessions in the evening, which would help children also feel comfortable with their peer ones.
Yes. And the older children also feel very confident that they are teaching the younger ones. And they also notice how the younger ones are learning, where they are lacking. And also give them an experience like, this is how they are also lacking in some ways. So it is definitely a learning experience for both of them. So cross-age peer tutoring is definitely an experiential learning method. And student-generated test questions. This is a really interesting experience, because when you come to difficult concepts like multiplication and division and word problems, you can ask questions from them. You can ask the questions from the student themselves and then solve it on the board.
This
That is-
also we discussed earlier in our classes.
Yes.
Asking the children to frame questions. This is what many a times we don't do as math teachers. We ourselves frame the questions and we ask always to solve the sums, and or either to decide on the operation, what they are going to perform to arrive at the solution. Instead, you give the solution and ask them to frame a question for that, which enables them to understand For this solution, what could be the question? What are the different ways to word the question? Not all children word it in the same way. So we come at almost like 40 questions. Some may be of course similar, but we will get 40 different questions where we can discuss those questions and tell children these are the different ways in which the questions will be worded. As teachers, I think all of you would agree, many a times when we give an addition problem, at the end of the addition problem, this so and so had this many toys, the other one had this many toys, find the sum altogether, or find the total number of toys altogether. This some of the keywords: altogether, total, sum, put together, in
Increase.
all these words we always related to the addition problems, but it is definitely not so. Would you all agree with this, teachers? These kind of words can definitely be reworded in a multiplication problem also. Am I right? That is why, yes, somebody has said yes in the chat. That is why when they come to the classes, say like 3, 4, and 5, they are finding it very difficult to identify an addition problem and a multiplication problem. Because when we ask them to look at only the keywords and go for the operation, this is definitely not accepted and not at all encouraged in the formative years. Don't give them the keywords at all. Don't give them. For that matter, leftover, remaining. All these can also be used for both subtraction as well as division. So, for example, say the same question using the word altogether, I gave you one question. The same can be used as a multiplication problem, saying that there were these many apples or whatever it is, or fruits in one particular basket. How many could be in 5 such baskets altogether? So there again I use the word altogether. So what happens immediately? Many children, they are so monotonous. Or altogether means teacher told me to underline the word altogether, so it is an addition problem. So simply they add and keep. This happens in many cases. We have observed this, and in our school we have done away with these, giving them with the keywords. We are not giving them the keywords even in the first standard level. We are framing the questions in such a way that the child has to understand. First, understand the question. Before understanding, she must be able to comprehend the question. That is very important. That is why we always see to that the language that we use in the real life problems should be as simple as it is for them to comprehend. So first step is to comprehend the question, then understand the question, then visualize the question, then decide on the operation, what has to be done, then apply that concept, then arrive at a solution. So these are the steps that a child has to do before solving any real life problems. If it is a direct question, there's nothing to worry. Just subtract this from this or add this from this. It is very easy for them to do. Everybody scores very well. But when it comes to applications in real life, the children find it very difficult to differentiate between an addition problem and a multiplication problem, just because as teachers, we give them these keywords before itself in their lower classes, say 1 and 2, saying that these words, total, altogether, find the sum, put together, then in all these words mean only addition. Definitely it is not so. Those kind of words can also be used in the multiplication problems also. So please, teachers, don't insist on only these keywords to solve the real life problem questions or say story sums or word problems. Please avoid using such keywords. Usually children underline the keywords and they start doing that. Please don't encourage that. For that matter, even subtraction and division, they both have some same type of words. which the child has to understand whether it is a subtraction problem or it is a division problem. That's what. So let us follow the steps, like how the child will be able to perform. First, the child has to comprehend. So the language should be very simple. Then the child has to understand what is the problem about. Then decide on the concept or the operation that has to be performed. Then start applying the concept to evaluate the problem or solve the problem. Then arrive at a solution. And many a times we also ask the children to check the solution, whether it is right or wrong. The last part is to check the solution. And there are different ways to check the solution, like when it is a subtraction for a problem, we always ask them to check using the addition method. And whenever it is a division problem, we always ask them to check using the formula of multiplication. So all these definitely have to be insisted on. So teachers, please see to that from now onwards, we'll stop giving them these keywords and asking them to solve this. So please keep this in mind. Let us reword the questions in such a way that children will be able to perform better. They will be able to visualize the problem in a better way and then arrive at the solution.
Now the next activity can be a fish bowl. What do you mean by a fish bowl? We all know that in a class of 40 or in a class of say 35 to 40, it is not possible to give an experiential activity to all the children all the time. Of course,
Yes.
few activities can be done by all the children, but some activities where the concept can be explained through experiential learning cannot be done by all the children. So in that case, we can have if the activity is called a fish bowl, where we call 5 children or even 2 children forward and do the activity and demonstrate it to the class, and all the children watch them. So it is just like 4 or 5 fishes in a fish bowl, and all of us see the fish bowl. So it is like that. So all the children in the class watch the children do the activity. For example, when we start teaching circles in class 4, we can make a child stand in the center and then call 5 or 6 children, say maybe 10 children, to hold their hands and make a circle. So this is an activity that can be done inside the class by calling only 10 or 11 children, and the concept of what is the center. There's a girl who is standing in the center and all the children are equidistant from the center, which means the distance from the center of the girl to any other girl is the radius, and we can call another girl to draw a circle where all the children are standing. That would be the circumference. So all this experiential learning activity could be done by calling some 10 or 11 children from the class who would like to volunteer. So those kind of activities are called fish bowls. So in the class where the strength is 40, we can always have experiential learning by doing an activity, by calling a fewer number of children to demonstrate before the class. So with that, all the children learn.
In lower classes, when we teach ordinal numbers, this is very, very easy, because making them stand one after the other, forming a queue to get something from the teacher or come near the blackboard to solve the sums. If they are standing in a queue one after the other, you can definitely teach the concept of ordinal numbers. It will be easy for them to understand the ordinal numbers and their number names. And of course, in the PT class, if the PT teacher is conducting a running race, 80 meters running race or something like 100 meters race, the person who comes first takes less time and the person who comes last takes more time. This concept of coming first and last and the time taken by the person who wins the race is definitely applied in class 5. I think teachers, you all agree. Many a times children confuse these answers. Whenever it comes to time and the race, it is a person who comes first takes less time, when we ask them to arrange these kind of decimal numbers or the time taken by them in seconds or minutes in the order, they always confuse. So this can be done in the PT class. Ask them to observe, record the timings, and find out the person who came first, the time taken by that particular child, and the child who came last, the time taken by that particular child, compare both, and then arrive at a solution. So these are the things which the child can definitely experience even in their PT classes. So there, of course, mathematics is involved. So they need to understand how decimals are arranged in ascending and descending order. So please take them to the PT class, give them the fun of enjoying the PT class, the activities that are conducted in this PT period, and make them understand the concept of decimals and the time taken by them in different programs in athletics.
Yes, ma'am. And even you can call children of different height to stand 4 or 5 children and ask other children to, name the child who is tallest, name the child who is shortest. So all these can be done in class 1. You can just call 5 students with different heights and teach them the concept of tall and short. And through games and
Give
quizzes,
them
I
a
think.
stopwatch and ask them to record the timings. Yeah, it is always the teachers who record the timings. Let it be an fun activity for them or an experiential learning activity for them. Give them the stopwatch and ask them to record the timings. So they will easily find out the difference between the timings, and then they all observe the timings, and then it is easy for them to understand that concept.
And games and quizzes, of course, they, as a child, I think nobody forgets the question for which they gave a wrong answer. Isn't it? They always remember, at least for 6 months, they would always come to me and say, ma'am, this question I told wrong in the quiz which you held that day, but now I learned how to. Games and quizzes are so dear for them. They want their side to win. And any answer that is given wrong, they never forget for a long time. They think, oh, this was the concept and I just gave the wrong answer. Games and quizzes and making mnemonic. So say in class, when they come to class 3, they always confuse between ascending and descending order. So I would always say A is for ant. So how is the ant? The ant is very small. So in ascending order, the smallest number comes first. Descending order, D is for dinosaur. So I make them draw the head of a dinosaur there. So how is the dinosaur? They say, ma'am, it's very big. T-Rex, this, that, and some commotion they will do. So in descending order, which number comes first? The biggest number comes first. So if you teach them with the mnemonic, like A in ascending is for ant, D in descending is for dinosaur, relate to something that is small and big, then they never confuse between ascending order and descending order, because many times we see we don't teach that. For descending order, they would have arranged the numbers correctly, but they have written it in ascending order. So it is not the problem with arranging the numbers, but writing them in ascending or descending order.
Even in subtraction, we tell them MS Dhoni. M
Yes.
stands for minuend, S stands for subtrahend, and D stands for difference. So the minuend, M, S, D, MS Dhoni. So they understand that minuend is always the bigger number that has to go on the top. They always confuse with which is minuend and which is subtrahend. That the confusion is there for the children. So minuend, subtrahend, then the difference. So these kind of small techniques, if you give them, it will be definitely helpful for them. And of course, they really enjoy these kind of small tips that we give in their way of learning, because these are the words which they are very, very familiar with. Like the ma'am said, dinosaur and ant and all, they will easily relate. Even in class 1, we always tell them ant is very small. Always start with the ant when it is an ascending order. When it is dinosaurs, start with a big number. So like if you give it with a lot of expression and with lot of examples and with this small tips, they love doing those things.
And again, in division also, they get confused between dividend and divisor.
divisor.
How many times you explain? So we would always tell that line is the bus stop and the number inside is waiting in the bus stop for end. So that it is end, so it is dividend. So relate with some kind of fun thing so that they remember all those things clearly. Because you can't tell the dividend is the bigger number, the divisor is something that divides the dividend. They get so confused. Quotient and remainder, they are very thorough, but dividend and divisor, they get confused. So you can make a mnemonic and give for them. And of course, field trip activities, if you can take them to some interesting places, that of course, again, involves a lot of planning and the permissions and all that. But that is one of the experiential learning activity. But of course, we can make use of all the other things which is possible to do inside the class. So these are all few experiential learning activities. So what is the use of experiential learning activities? They help students to remain focused, learn differently. It is the same concept they are learning, but they are learning it differently and they are learning it faster. What we take 2 classes to teach them, if we make them to do the concept, they learn it as soon as they do it. That happens in like 15-20 minutes. So they learn faster. Of course, there are n number of useful things for the child. She's socially learning. She's learning her leadership skills. All those things are there. But these are the broad uses of experiential learning activity.
And before going to the next one, so we have suggested some of the experiential learning activities here. So before going to that, let me put you this concept. How would you teach them, or how would you give them an opportunity to identify or differentiate between a curved line and a straight line? Teachers, how would you differentiate or identify between a curved line and a straight line? What kind of activity can be given to the children to make them understand this particular concept? This curved line and straight line, of course, it is there right from class 1. And it is taken to the next level in class 4 and class 5. This is there in NCERT syllabus in class 6 also. Yes, ma'am. Please, ma'am. Mahalakshmi, ma'am.
Ma'am,
Yes, ma'am.
curved line
First
will
aid.
have bend.
In the circle, we have bend.
Yes,
Ma'am.
curved line will have bend, but straight lines will not have any bend.
Ma'am, can I explain?
Okay, ma'am. Okay, ma'am. Yes, ma'am. Anybody else?
Ma'am, for straight line, we can take them the scale and we can show that as an example using a ruler. And for a curve line, we can take a thread and bend, and it is a curve line.
Yes, ma'am. We have an example here, very simple example. Shobna, ma'am, go to that particular slide. That particular slide.
This is a jump rope or a skipping, as what we would
Whatever
call.
it is, it can be simply a twine or a long thread, thick thread, or it can be a skipping rope or anything like that. If you pick up the rope and if you hold it tightly on both the ends, you get a straight line. And suppose if you are loosening the rope a bit, even a little bit, it becomes a curved line. So,
What we have
ma'am, I'm not talking about standing line and sleeping line. I'm talking about curved lines and straight lines.
This is from our textbook.
This is from our textbook. This is what we have also given in our in-house publications, which makes them understand that concept very clearly, because bringing a rope to the class and just ask them to bring a skipping rope, because many of them, they bring skipping rope for their PT classes. So it's very simple. A straight line does not bend at any point. It goes straight in both the directions. Whereas a curved line has its bend in some places or the other. Yes, ma'am. We'll go to the next one. Coming to
Next
the
one,
shapes.
when we teach shapes, we ask the children in class 2, we ask them to do a paper boat with that. So first they take a paper, any paper that is rectangular, then we ask them to make it as a square. And as they fold, they see the paper in different shapes. And then at the end of the day, they make a boat and they also identify the number of vertical lines, horizontal lines after the boat is made. So, and then also obviously, if you want to add more questions, we can ask, have you seen a boat? Yes, on a river or something. And we can also move to like make it a value-based question as to should we keep our rivers clean and where should we throw the garbage and all this. All those value-based questions also can be included. So we make experiential learning for class 2. We give one of the experiential learning is to make a paper board. And for odd and even numbers, we have a hopscotch that is all there at the school.
This is the
So they
common activity. We do it inside the classroom or in the lab activity or in the quadrangle or in the playground or wherever place is available. This is a very simple activity with a color chalk piece. The teacher can ask them to. The teacher herself can make this, what to say, these boxes, put numbers inside the boxes. And if you look at that, there are a lot of ways to do this activity. It is not only odd and even just skip counting also can be done. So if she wants skip counting, she can go by 2s or 3s or whatever it is. So this particular activity can be used for many concepts. Supposing if she wants only odd and even, all the even numbers will be colored in the same way, all the odd numbers will be colored in the same way, and the child has to jump only in those boxes. So it is like that. And same way, if we do skip counting in 5s or in 2s for simple, for that matter, when we are in class 2, we start with 2s. So they can skip count in 2s. So there are many activities like this, which will make them enjoy, understand even more better. And because they are experiencing that particular activity in the classroom itself. This, of course, we give different names to this particular game. And this game, we can make use of it in our own classroom itself to make teaching math more effective. Yes, ma'am.
we have and we have place value cups where they can create a number and ask they pair up. They come in 2s. The one child creates the number and then the other child has to read it. From this, we can ask the place value, face value, and all that. So we can the permutations of making this activity is endless. It uses only
flashcards are very useful at this stage.
Only paper cups. They are very easily available. So with that, you can make it. And for higher classes, for class 4 and 5, tangrams. Tangram is actually, it consists of a set of 7 polygons, which is 5 triangles, a square and a parallelogram. With that, you can make n number of designs, starting from animals to birds to whatnot you can make. All of you can have a look at, in Google, and then
I think many of the schools will be having this kit. At least if 10 kids are available, you can ask children to form in groups of 4. If for a class of 40 children, if they are 4 in a group, definitely they can come out with wonderful designs using the tangrams. Of course, this using tangrams and creating designs help them to develop logical thinking, perceptual reasoning, visual, spatial awareness, creativity, lot of creativity inside that. Actually, they say 1,500 designs can be done, but the latest analysis and statistics say that there are even more than that. And when they come to the higher classes, actually this concept is used for understanding congruency in triangles, which is very, very difficult for them to understand when they come to class 7 and 8, because they don't understand what is congruency. So if this is emphasized in class 4 and class 5, this gives them a room for understanding in their higher classes. Of course, the perimeter and area part of it also can be discussed. So tangram itself is an experiential learning activity.
And we do with toothpicks, we do 3D shapes. Yeah, they can use clay dough, or even they can bring chapati dough from home and then share it with their friends to join the corners. And because of this, they will understand the number of edges, because simply you draw on the board and keep explaining the edges, it is very difficult to make them understand the edges, vertices, sides, faces, everything. When they do it, it is very easy for them to count how many edges are there, how many vertices are there, how many sides are there, flat side. So all that is very easy. So class 2, they do plane shapes,
Plane shapes.
and 3
Ice
and
cream sticks can
1,
also
2.
be used instead of matchsticks, or straws can also be used. Whatever is available with them, which is uniform in length, can be used for
Yes,
making
even
these kind of plane shapes. And
broomsticks also we can ask them to cut
Yes.
into equal size and then bring it to the class. So always something very inexpensive, but can be used to teach the concept, can be used by the teachers. And for fractions, we use something called as ice cream sundae, where they make their own flavors and then write what is the fraction of each flavor. For example, here one is brown, so here 10 scoops of ice cream are there. One is the chocolate ice cream, so 1/10 is chocolate ripple, and then mint for 1, 2, 3, 4 green mint is there, so 4/10 is mixed chocolate chip. So they are very interested to do this and then understand what fractions are all about. So these are all few of the experiential learning activities which
there
are
are lots of activities we have done it. We have included in our in-house publications. Again, teachers, I would like request you all to have a look at it and give your valuable feedback. Of course, some of the schools have already ordered for our in-house publications. I request other schools also to go through it and give your valuable feedback. We will definitely incorporate whatever we have not done. And in case if we need to improvise on any other topic also, it will be helpful for us.